Hello, everybody. My name is Andy Rivenis. I'm a product manager for Database and Memory. In this session, we're going to talk about the new feature in-memory spatial tables and full text columns. There's actually two features. They're based on the same underlying technology, but we've added in the ability to have in-memory spatial tables and full text columns, in-memory full text columns in the column store, as to allow you to take advantage of some a little bit different formats than traditional relational formats. So there's some required setup to take advantage of these features. They're based on in-memory virtual columns. So you need to have in-memory virtual columns set to either enable, which means we'll automatically populate virtual columns that are defined on the tables that have been enabled for in-memory, or you can set in a manual, which means you'll have to manually enable those virtual columns for population. So we recommend setting in-memory virtual columns to enable. For in-memory full text columns, there's a few more requirements. You'll need to set up extended string support. So that's setting the max string size equals extended, which will require a couple of changes in the database to support max string size. There's documentation available in the reference manual if you look up max string size to walk you through that. In addition to that, if you choose to use a custom indexing policy, since in-memory full text columns is based on text feature, you may need to add the CTX app role or execute privilege on the CTX sys CTX DDL package. That's if you use a custom indexing policy with a full text column, in-memory full text columns. And all of that, I should mention, is available or documented in the in-memory guide to help you through, so you don't have to remember all of that from this session. So let's talk a little bit about in-memory spatial tables. Database in-memory supports populating spatial tables in the column stores. And some operators can be leveraged, but really the new thing is the ability with the SDO filter operation to take advantage of essentially spatial indexes without having to create a spatial index, if that makes sense. And so what we'll do is we'll keep track of min-max values in virtual columns in the column store when we populate an in-memory spatial table. And we have a new clause, in-memory spatial, that you can specify. So we'll do under the covers, we'll create virtual columns that replace the need for having to use spatial indexes or create spatial indexes when you use the SDO filter operation. So I have a couple examples for you. So I used these examples come out of the Spatial Graph Developer's Guide, so you can actually go try this yourself. But what I did is I created the city points table, and then I have a shape geometry defined. And what I've done is created an index, a spatial index on that. The traditional, this is how it would work without database and memory, just how a spatial table would work. And the point is to show you the usage of the spatial index, and then we'll contrast that with database and memory. So in this particular case, I run a query. We see from the execution plan that I've used the index that I created, the spatial index that I created, and that's how normally spatial would work in Oracle Database. And you can see that, or that example, and go review that in the Spatial and Graph Developer's Guide if you're interested. But the other part of this is then we could populate our city points table in the column store. So in this case, I've enabled the city points table to be in memory. I've populated that. And now I'm going to run a query that accesses a point. So I'm going to look for one of the cities in the city points example based on an X coordinate. And we see that we access that table in memory, table access in memory full. So we're accessing the city points table in memory. And we see that we've pushed down, if you notice the in memory, both a filter and the in-memory clause in the predicate information, we see that we've actually pushed down that filter predicate so that when we scan the city points table in the column store, we're going to use the normal filter predicate processing, and notice the sys_nc label, that's a virtual column that will then scan to find that coordinate and return that. So that'll be faster in the column store than it will be if it wasn't populated in the column store. But for our purposes, when we have spatial enabled, you can actually specify on our geometry column, which is again that shape column as part of our city points table, we can actually say alter the table to be in memory, and then we can specify in memory spatial in our shape column. And what that's going to do is that's going to, I've printed it out here, that's actually going to use or create special in memory expressions for the virtual columns associated with the shape geometry. And that's going to allow us to then avoid having to create a spatial index. So effectively, specified in-memory spatial creates a spatial index within the column store automatically for you. And the neat part about that then is that we can run a spatial query and take advantage of those in-memory expressions or those populated spatial indexes. You can see that in the filter, in the predicate information. We can take advantage of that in the column store itself. So that can give us some significant performance improvements when querying spatial data, and we've enabled that in the column, when we've enabled that in the column store, so that you can take advantage of that without having to create external spatial indexes. So that can save some space. It takes up less space in the column store. We take advantage of compression. And so then you can take advantage of the SDO filter with an in-memory spatial table. And that's really what this feature is all about. So now let's move on to in-memory full-text columns. So in-memory full-text columns allows you to use the contains or JSON text contains operators on in-memory text columns or text-based columns populated in the column store. So we support character, varchar2, clob, blob, and JSON data in the column store in this for in-memory full-text columns. So rather than having to create a text index separately in the database, we can populate this or create this in the column store when you've populated the in-memory your table in in-memory column store. So hopefully that was clear. My example here is a little different. I have some data that I created, and so we're going to populate our, what in this case is called the Chicago data table in memory, and then we're going to query on, see how many rows in that Chicago data table have a district of 9 with a description like battery, so percent battery percent, so that we're going to scan any description values that have battery within them. So typical, maybe not typical, but a text type query against the Chicago data table. And we've populated that in the column store. So now we're going to see that we're just simply doing a description and pushing this into in-memory. You see description not null, and we're going to push the district equals 009, and then our like clause, and we're going to scan the column, description column in the column store and return any rows that match that. So a typical database in-memory query for a table that we've populated in the column store. But since it is a text field, description is a text field, if we populate that table in the column store and specify in-memory text. In this case, I have the description table and I'm using a custom policy. You don't have to use a custom policy. That's just part of Oracle text. What will happen is we'll actually create under the covers, as we populate the table, an in-memory, a special in-memory expression similar to what we did with in-memory spatial, but now we'll do it with our full text columns. And notice that you see in the data default, the context index, if you will, of description and the definition of it. So you can see that we've actually created another virtual column that can then be used when we query that data in the column store. And so now we have a slightly different query, only because we're going to use the contains clause so that we can take advantage of our in-memory full text column. And you see table access in-memory full. And we're using the Chicago text rather than Chicago data, exactly the same tables, just so that I can have both of these as an example. And notice now in the predicate information, we have our SIS context, and we're taking advantage of that virtual column in the column store that we created when we specified text in our in-memory clause, so that now we can do that searching directly against in the column store, direct against that virtual column, rather than having to create a separate text index. And so that's how in-memory full text columns work, being able to search data very, very fast and text type data, whether it's a varchar, as a clob. I mentioned the different data types that are supported. So now you can do searching of this kind of non-relational type data very quickly in the column store. And since we support also JSON data, it makes searching JSON data very fast and can be a real advantage to certain applications. Again, where can you get more information? On our blog, we have our resources page, we have our technical articles in the blog, and then in addition to that, I have some links here that can give you an idea of the different places where you can find more information about database in memory. Thank you.